Hi students, I am Sandhya, Assistant Professor, Department of Mathematics and SNS College of Technology. Dear, come and recap the previous class topic now.
Hi everyone, I am Diyashree. In previous class we saw about characteristic equation, eigenvalues and eigenvectors. I am going to say the application of each of them. In characteristic equation we use them to solve eigenvalues and in differential equations. In eigenvector we use eigenvectors in PCA and quantum mechanics, and we use eigenvalues in PCA and chemistry. Thank you.
So in this class we do some activity. Okay, anyone of come friend? Can you familiar words of first unit? Okay, so in this first unit is, what is the first unit? Matrices, eigenvalue, eigenvector. Okay, so here she is writing the familiar words. Okay, so what are the familiar words? So first one is characteristic equation. Okay. Okay. So write all the familiar words. So next, all of you mean same. C1. No. Write fourth point. Fourth one. C1. Okay. I will be same. Writing C2. Next. Okay. What are the words you know in the first unit? Okay. Diagonal matrix. What is that? Upper triangle matrix, and then determinant of A. Wait. Symmetric matrix. Right, symmetric matrix. Yes, why? Next, synthetic division. Next one is synthetic division. Next, rows. Next, next one. Diagonal elements. Please say diagonal elements. Okay. Next. Lower triangle matrix. Next. A transpose. A inverse, 15th A inverse. Lambda. Next. Normalized minor matrix. Properties. Orthogonal. Properties. Next one. Pairwise orthogonal. Main diagonal. So 20th is main diagonal. 20th is main diagonal. It's enough. There are 20 words you know. Okay. So first one, all of you explain what is characteristic equation. Any one of you explain the characteristic equation. So anyone explain what is what is that eigenvalue, whatever it is. Okay. So if it is what is eigenvalue? What is eigenvalue? Eigenvalue is denoted by the symbol as lambda. Okay. So similarly, you explain eigenvector C1, C2, C3. Okay. So come friend and say what is characteristic equation. Anyone?
To explain about the characteristic equation. Characteristic equation is obtained by solving the matrix. In that there is a 2 into 2 matrix and 3 into 3 matrix. By solving the 2 into 2 matrix, we will get from lambda square minus lambda and so on. By solving the 3 into 3 matrix, we will get from lambda cube minus lambda square and so on. And eigenvalues are obtained by solving the characteristic equations. And the eigenvector is obtained by the formula determinant of a minus lambda I into x equal to 0.
Okay, ma'am. Very good. So anyone come and say what is C1 and C2, C3? Anyone?
So I'm going to explain about C1, C2 and C3. C1 is nothing but the sum of the leading diagonals of the given matrix. C2 is the minor of the leading diagonals of the given matrix. And C3 is the determinant of the given matrix. And matrix is a rectangular array of elements arranged in rows and columns.
Okay. Explain diagonal matrix. Javani.
Diagonal matrix, the element only present in diagonal are called the diagonal matrix. Upper triangular matrix, the element present in the upper, in the lower are zero, then it is called the upper triangular matrix. Symmetric matrix, excepting the diagonal elements, the other elements are same, then it is called a symmetric matrix.
It's identity matrix.
Identity matrix is, I said in row 1 0 0 0 1 0. The diagonals having 1 1 1, then it is called the identity matrix.
Okay, ma'am. Very good.
So row means the element present horizontally in a matrix is called row, and determinant of A means how we can take determinant. The way we take determinant is called determinant of A, and A inverse means A transpose means the given matrix we change row into column and column into row is called A transpose.
Next, I'll talk about the next topic of adjoint A. Adjoint A is something what we'll find, we'll say it as transpose matrix of a cofactor matrix, and matrix, how do we find adjoint A is like the formula is Aij, the whole transpose is called the formula for adjoint A. Next one, diagonal elements. Diagonal elements is what something like the row and column will be the same, but the elements in the diagonals won't be the same. And next, lower triangle matrix is like the zeros will be in the upper side of the matrix, and the other will be elements which is remaining in the matrix.
The sum of the eigenvalues is equal to the main data elements, and the product of the eigenvalues is equal to the determinant of A. The square matrix A and its transpose have the same diagonal elements.
So these are the properties of eigenvalue and eigenvector. Okay. So in this activity, what is you learned in this class? Anyone?
This activity helps us to learn new terms, important terms in maths, and learning maths more enjoyable and interesting. Thank you.
Thank you, ma'am.